So what we'll do on the left hand side of the log equation, so let's start from here, is to use the rule. So knowing that we have a constant in front of log, this becomes a power. So we're going to have log 2y to the power 2. So this is y squared. On the right hand side, when you got two bases the same, you can, and you're plusing, you can multiply the two terms here, which will become log 2 root 3 times x, which is root 3x. Okay, now because these are both in equal with each other, they're both equilibrium, this means that y squared must equal root 3x. So in fact, our first pair of equation to solve would be root y squared equals root 3x. Alright, not bad. So we're off to a good start. Now, how about the next part? So let's start with this one. So 3y to the 3 to the power y equals 9 to the power x. Here we need to consider what the 9 should be. The way this works, both bases must be the same. But thankfully we know that 9 is the same as 3 squared. So using 3 as a base, we can multiply 2 against x. So we should have 3y equals 3 to the power 2x. This immediately implies that y must equal 2x, because if these are the same, then these two must be the same. Okay, that's good. Now it's just a case of popping it back in here and solving. So what does this mean? So substituting y equals 2x into here, we should have 2x squared equals root 3x. Expanding, we should get 4x squared equals root 3x. Now putting everything on one side, this should give us 4x squared minus root 3 x equals 0, and factorizing x will give us 4x minus root 3 inside. Hence our solutions are x equals 0 or x equals, so plus and root 3 divided by 4, root 3 over 4. Not bad. So, and then popping this into the y equation, this means when x is 0, y is 0, or when x is this, we have 2 times root 3 over 4, which is just simply root 3 over 2. So what do we have? So here we got log to the base 2x equals 8 plus 9 times log x to the base times 2. So so what do we see here? So first thing, so we notice that this part here and this part here are actually different. One's got 2 at the bottom and x up, one's got x and 2 there. So before we even consider solving this, we should try and at least make them the same. To do this, I mean, thankfully, we can always, take the reciprocal and this will solve it for us. So what do I mean by that? Well, let's copy out everything else. Here, what this means that the cool thing of this feature, if we take the reciprocal, then this will become the same. So this is 1 over log 2x. So reciprocal of this is 1 over that. Now all we do at this stage is use some nice cool algebra. So I would say let y equal the log 2x. So let y equal log 2x. This means that we're going to get y equals 8 plus 9 over y. Now multiplying y across, because we don't like fractions. So what happens here? We should get y squared equals 8y plus 9. And notice that we have a quadratic expression. Hence, throwing the whole guys across, we should get y squared minus 8y minus 9 equals 0. Cool. So I mean, like at this stage, it's quite easy now. So here, let's have a try. Yeah. So this means factorizing this. What do we have? So because we got 9 here, I will try 9 and 1 because that gives a difference of 8. So factorizing, we got y minus 9, and we need to plus 1 to get minus 8. And this equals 0. Hence, we should have y equals 9 or y equals negative 1. Now, guys, the finale. So, what do we do? Now we just replace the y's with the log for original log equation. And that means we're going to have log 2x equals 9. This implies that we log x on its seat, raise a 2 and raise a 9. We get 2 to the power of 9. The second equation, log 2x equals minus 1. Same thing, we log x in the seat, raise the 2 and raise the 1. And that's it, guys. Here's the answers. I mean, I'm not going to bother doing 2 to the power 9, but yeah, this should give us what we need. Now, there's one key issue here. Firstly, notice that we have a 2 and a 4. In other words, our lower base are not the same, meaning we cannot merge these logs together. So that means we have to use another method, or at least try and make this the same. Well, what I would personally do, because they're different, then give them different names. So I'll say straight off the bat, I'll let this entire term equal a, so a equals log 2x, and b would equal log 4x. Okay, so this implies now that we're going to have, of course, a plus b equals 2. So you can see where we're going. Yeah, we're looking to get two simultaneous equations. Alright, so let's have a go. So suppose this is the case. How can we also make this the same? Well, let's work with log 4x. Now, in order to rewrite this, all we have to do is raise the power 4, raise the 4 up and raise the b up, and then isolate the x. So x would equal 4 to the power b. Likewise, for equation A, you lock the x in position, raise the 2, and then raise the a. So basically, you're pretty much just raising their station and position up. That's how I kind of envision it. Now, how can we formulate to make these two equivalent? That's another way to do this. So to make these two equivalent, we need to somehow multiply 4. We need to somehow reduce this factor. So we know that 4 is also can be written as 2 times 2 to the power b. And this is pretty much the same as 2 to the power b dot 2 to the power b. And of course, this is the same as 2 to the power b squared, because there's 2 lost terms. And of course, this is the same as 2 to the power of 2b. That's it. And here we just imply that 2 to the power 2b is now the same as 2 to the power of a. Done. So what does this tell us? Given that the two bases are same, this implies that the powers must also be equivalent. And guys, looks like we did it. So if a equals 2b, now all we really do is substitute this back into a plus b. Replacing a with 2b, we're going to get 2b plus b equals 2. Hence we have 3b, which implies b equals 2 over 3. And lastly, to get a, it will be 2 take away 2/3. And I believe that should give us a nice a equals 4 over 3. That's it, guys. We've pretty much solved it. So now, that means, what does this mean? That means we can work out the final answer. So this means x is actually equal to 2 to the power of 4 over 3. What do we have here? Here we got log 4x plus 2 times the log of base x at 4 plus 3 equals 0. The first thing you want to do here is always try and make everything in the same form. In other words, we want to put everything in the form of log 4x, because this will be easy to evaluate. So here we go, sort this part out. Now, what do we do? Well, copying everything out, we should have log 4x plus, here what we can do to invert this, there's a technique where if you take the reciprocal of this, you would get this form. So this would now be 2 times 1 over log 4x, so this is the same, plus 3 equals 0. Okay, so here we could just use some cool algebra and say what? Let y or something, so yeah, let y equal log 4x. So what do we have? Let y equal log 4x. Now we should have y plus 2 times this, so 2 over y plus 3 equals 0. So multiplying y across, we should get y squared plus 2 plus 3y equals 0. This can be written as y squared plus 3y plus 2 equals 0. So the purpose of this is to, of course, when you get expression in this form, you want to write this as a quadratic because it's easy to solve. And because we have these kind of figures, this is dead easy to factorize. So using simple rules, to make 2, you need 2 times 1 to plus 3, 2 plus 1. So we're going to y plus 1, y plus 2. Hence, we're going to have values of y equals -1, y equals -2. Cool. From here, what do we do? Well, we found y, so now we can put log 4x back in. This should give us a log 4x equals -1, log 4x equals -2. Now for both of these, using a standard log form, what I will do is just, keeping x fixed, you can bring the 4 up and the -1 up. So we're going to have x equals 4 up to the power of -1, and x equals 4 up to the power -2. And that's it. And of course, 4 to the power -1 is 1 over 4. 4 to the power of -2 is 1 over 4 squared, which is 16. Now the first equation, we have 8 to the power y equals 4 to the power 2x plus 3. And the second, we have log 2y equals log 2x plus 4. Now the first thing I always say to know is to check if the log bases are the same. If they're the same, this implies that these are the same too. So this is equivalent to that. So right off the bat, we know that y equals x plus 4. So that's already a possibility. Now we look back at the first equation and we ask ourselves, what do we do? The problem with this one is that now the bases are not the same. One's an 8 and one's a 4. Now to make it the same, we need to somehow manipulate the powers. This is kind of like a mental skill. So you need to figure out what 8 and 4 both are powers of. We know that. So straight off the bat, we need to know that 4 is a power of 2. So it's pretty much 2 to the power 2. And 8 is a power of 3. So 2 to the power 3. So yes, 2 would be the base value. However, that means we need to multiply each term here by 2 and by 3 and 2 respectively. So rewriting the first equation, we should have 2 to the power 3y equals 2 to the power 2 bracket 2x plus 3. Because of this, now these two are the same. This implies that these two must also be the same. So yes, our second pair of equation will be 3y equals, multiplying this out, 4x plus 6. And this can be solved simultaneously with y equals x plus 4. Well, yeah, then that's it. Now we're just going to pop this into this equation and solve it easily. So knowing that y equals x plus 4, we can say that 3 times x plus 4 equals 4x plus 6. Expanding this will give us 3x plus 12, and this equals to 4x plus 6. Subtracting 3x across and 6 should give us a nice clean x equals 6. Alright, and that means popping this into the y equation here, this should give us y equals 6 plus 4 is 10. And that's it, guys. That's pretty much how you solve a simultaneous log equation. Let's try and find the value of x from this log equation. So what do we do? First thing, let's check, are the bases the same? Yes, there are. So bases the same, check. Could we combine it? Yes, we can. There's a negative sign. Is there something, blocking it? Yep, this 2 is obviously in the way, so that can, of course, get out of the way. So let's try and sort this equation out. Well, first things first, using some log rules and the power rule, if a number is in front of the log, this means it becomes a power. So this means we have log 3, x becomes x squared. And of course, copying the rest of them should be the same. Now, using the laws of the subtraction laws, this becomes a law of log division. So these two end up dividing each other. So we're going to have log 3, and inside we're going to have x squared because it's in front over the negative part, x plus 4, and all of this equals 2. Now it's a case of just opening this up. So the way this works, this stays in position, and all we do is raise the 3 up and the 2 up, so this becomes 3 squared. Now, of course, this is just simple algebra, so multiplying x plus 4 across, we should get x squared equals, this is 9, so we're going to get 9x plus 9 times 4, 36. Of course, rewriting this as a quadratic, we should always do in this form. Now, factorizing is the easy part, so factorizing this should give us x minus, so let me think again, to get 36 we need what, 9 and 4, nope, we don't want 9 and 4, what else do we want? Well, I'm not too sure what we want, so I guess we should use a quadratic formula. Okay, so let's make some space. Okay, so yeah, so this part we literally solve for x, so that means, I'll just use a quadratic formula honestly. So let x equal here, so we're going to get minus sign, so we get 9 plus minus square of 9 is 81, minus 4 times 1 times minus 36, so 4 times 36 all over 2 times 1. Now just popping this in the calculator, we should get 12. Okay, so alright, so I was wrong, so you could make 36 and 9. Oh yeah, you could have. So you get 12, and of course the other one I'm just going to use my head is 3. And that's it, guys. Literally that's the rules required. And yeah, so I hope this video helped, and please let me know for any other problems. Okay, see you now, and ciao ciao.